All right, so let's go on now. Now, I have to be a little bit more systematic about limits. And so let's do that now. So now what I'd like to talk about is limits and continuity. And this is a warm-up for deriving all the rest of the formulas, that I'm going to need to differentiate every function you know. Remember, that's our goal, and we only have about a week left, so we'd better get started. So first of all, there's what I will call easy limits. So what's an easy limit? An easy limit is something like the limit as x goes to 4 of x plus 3 over x squared plus 1. And with this kind of limit, all I have to do to evaluate it is to plug in x equals 4. Because, so what I get here is 4 plus 3 divided by 4 squared plus 1. And that's just 7 divided by 17. And that's the end of it. So those are the easy limits. The second kind of limit, well, so this isn't the only second kind of limit, but I just want to point this out. It's very important, is that derivatives are always harder than this. You can't get away with nothing here. So why is that? Well, when you take a derivative, you're taking the limit as x goes to x0 of f of x, well, f of x, let's try. Yeah, we'll write it all out in all its glory. Here's the formula for a derivative. Now notice that if you plug in x equals x0, always gives 0 over 0. So it just basically never works. So we always are going to need some cancellation. To make sense out of the limit. Now, in order to make things a little easier for myself to explain what's going on with limits, I need to introduce just one more piece of notation. What I'm going to introduce here is what's known as a left-hand and a right-hand limit. If I take the limit as x tends to x0 with a plus sign here of some function, this is what's known as the right-hand limit. And I can display it visually. So what does this mean? It means practically the same thing as x tends to x0, except there's one more restriction which has to do with this plus sign, which is we're going from the plus side of x0. That means x is bigger than x0. And I say right hand, so there should be a hyphen here, right hand limit, because on the number line, if x0 is over here, the x is the x is to the right. All right, so that's a right-hand limit. And then this being the left side of the board, I'll put on the right side of the board the left limit, just to make things confusing. So that one has the minus sign here. I'm just a little dyslexic, and I hope you're not. So I may have gotten that wrong, but okay. So this is the left-hand limit. And I'll draw, so of course that just means x goes to x0, but x is to the left of x0. And again, on the number line, here's the x0, and the x is on the other side of it. Okay, so those two notations are going to help us to clarify a bunch of things, it's much more convenient to have this extra bit of description of limits than to just consider limits from both sides.